Hello everyone, welcome back to the next lesson. In this lesson, we'll be discussing moving average method for forecasting. So let me take all of you back again to my Excel. Here I have prepared some data. Again, we have actual sales plotted against the different months. This is a monthly level actual sales data, and we'll be seeing three moving averages. Let us first begin with the average forecast. So in this, what you do basically, you take average of all the previous uh, sales data, right? So here is an error. So you have average of all the previous periods for the current method. Let me just track the formula. Yeah, so if you see, for March I have taken average of Jan and Feb. Now in April I have taken average of Jan, Feb, March. So you take any periods and basically an average of all the previous periods. So any point, any period you pick, that is going to be an average of all the previous period. That's an average forecast. So when you see the in the graph as well, the blue ones, let me just make this graph bigger for you. Um, Here the blue ones is the actuals. If you see, the blue ones is the actual sales data, and the average forecast is the orange line. And if you see, the blue data, the actual sales data has a lot of variation, and here is one of the outliers as well. And the average forecast is, you see, the average of everything. It has smoothened everything, the random variation of the outliers. So if you see, one of the benefits of the moving average, that it has not projected the outliers as the forecast. That was one of the major issue with the new forecasting, that it was projecting an outlier or random variation as a forecast. But um, the moving average uh, is not projecting, and it's basically averaging out the past history. So let me just minimize the graph again, and let us discuss the another variation. So we are discussing three variations in the moving average method. So next way is, now in this method you see, as a drawback, when you take average, the averaging really smoothen out the pattern, or it makes it too much stable, and it's not actually capturing the trend or the pattern. Trend is not the right word. So when you take 3 months moving average, it's basically uh, averaging the past 3 months, 3 periods data. Like for May, when you calculate, so May is going to be the average of Feb, March, and April. Again, if you take for June, it's going to be the average of past 3 months. So that's how you calculate for everything. And that way you can do for the 4 months moving average, 5 months moving average. You take past 4 months average for the current period, previous 4 periods average. So that's how you calculate different variations of moving average: 3 months moving average, 4 5 months average. And if you see the graph again, let me just zoom it out. Let us see how the forecast varies when we do a 3 months moving average or a 4 months moving average. Now here you see we have, so let me just remove the orange line, the average forecast. Yeah, so we have only the actuals. The blue is the actual sales, and 3 months moving average and 4 months moving average. So the one difference you see, the 3 months moving average doesn't require a lot of requires one less um, period to project, and 4 months moving average requires 4 months periods, or 4 periods to project. That's what's starting a little late. Then Another difference you see, the more you are averaging, there is a more lag while capturing the history or projecting for the future. Now if you see the 3 months moving average, it's capturing the pattern, you see more. But the 4 month moving average, it's it's low, or it's slow compared to the 3 months moving average, because it's the data is getting averaged out, or the smoothen out compared to the 3 months moving average. You can pause the video for a while and just take a feel how 3 month moving average is different for the 4 month moving average, and how 4 month moving average is reacting bit slow compared to the 4 month, the 3 month moving average. Like if you take this time phase, here you see from after April, from April, May, June, the data, the actual sales has coming down. But if you see the 3 months moving average, it captured the data real fast, and it is more close to the value. But if you see the 4 month moving average, it's not coming down that fast, it's lagging behind, right? And after the August, the 3 month moving average has again picked up the upward trend. Yeah, but if you see the 4 month moving average, it started picking up the trend at this point, but the 3 months moving average started picking up the trend bit faster. So the more you average out, the more lag you see in your projection. But another benefit is that uh, it smooth out the random variation into the data also. Like if you see the 3 months moving average has almost captured, or it's captured more this outlier compared to the 4 month moving average. The 4 month moving average has not projected this one into the future too much, but if you see the 3 months moving average, it has captured a bit, and it has given it as a projection for the future. So that's a drawback for the 3 months moving average compared to the 4 month moving average. So the more you do the average of more periods, you have uh, your random variation gets smoothed out. But there is another drawback into doing a lot of average, that the the model lags behind the actual pattern of the data. So let us discuss a bit more about the moving average in general as a forecasting model. First thing, like name model, this also can't predict the future, since it's depending upon the historical data. The um, you can't predict it much into the future. Like if you see here 3 months moving average for the September, if I take September 23, if I want to project the data, uh, September 23 I'm projecting the data, I'll need June, July, August data. But again, if sitting here in the September, if I want to project for October, I don't have this data with me. So here comes a drawback for this. Secondly, it doesn't capture the a trend or seasonality. um, it's just the data model is based upon averaging the previous some periods. It doesn't capture the trend. What is trend? Trend is the increase into the forecast of the actuals. And seasonality is a repeatable pattern which you see across the time period. Like every year in Christmas we have huge sales of ice cream or chocolates, or in summer there is a lot of sales of air conditioners. So that's the seasonality. Are there any repeatable pattern uh, across the time series or in a particular time phase? That's seasonality. So moving average fails to capture that. Another one of the biggest drawback of moving average, that it gives flash historical weighing, which means it gives the equal weightage to all the periods. For example, if I am taking 3 months moving average, and that 3 month moving average is an average of previous 3 months or previous three periods, and it has given equal weightage to all three of them. But as we know, the recent data should be given more value because it's more near, and the the near term forecast should be more closer to the near term actuals what we have, right? So ideally the more weightage should be given to the near, like March should be given the more weightage, second should be the Feb one, and least should be January. So ideally this is what should be happening, but the moving average gives the equal weightage. So there is something called as weighted average as well as a variation, which I have not plotted here, but you can do that as well, where you can, when you're uh, taking an average for last 3 years, you may, last 3 months or last three periods, you may give kind of 50% weightage to the recent period, and 25% you may give to the previous two periods. Different variations you can do in giving the different weightages, but yes, giving more weightage to the recent period is always an criteria. So that can be the another variation uh, in the moving average, which is the weighted average, which I have not plotted here, but you can get the formula easily on the internet. So this flaw of moving average, that doesn't give equal weightage to, right, it doesn't give the weightage as per the importance, is actually solved in the exponential smoothing method, which will be one of the models discussed in the lesson. Yeah, so that's it for what I had for the discussion for moving average method.